The successful operation of automation systems is heavily reliant on the use of discrete I/O signals, including inputs from sensors. These signals are critical in enabling these systems to perform their intended functions with utmost accuracy and precision. Using 24-volt DC is a safer and more common option for typical industrial automation sensors, given that many DC sensors operate at this voltage. In the realm of 24-volt DC sensors, it is inevitable to come across the terms PNP and MPN, as these are common and often confusing terms used in the industry. In this video, you will learn what a PNP sensor is. You will get familiar with the working principle of a PNP sensor whenever it detects or not detects an object near it. You will be demonstrated how to wire a PNP sensor to a PLC and provided tips to avoid common mistakes. And finally, you will learn how to test or identify a PNP sensor using a multimeter. Without further ado, let's jump right in. First, you should learn whether the circuit is designed for PNP sensors. To do so, here you have a DC circuit that includes a power supply, a 2-wire proximity sensor, and a load that is considered a light bulb. The PNP is shorthand for positive, negative, positive. The letter N in the middle of PNP, short for negative polarity, reminds you that the load should be connected directly to the negative side of the power supply. It is a simple yet effective way to remember which side the load is straight attached to. Once the 2-wire proximity sensor detects a target, it activates and facilitates the conventional current flow via the brown wire from the positive side of the power supply through the sensor. Then it exits through the sensor blue wire, through the load, and returns to the negative terminal of the power supply. As the 2-wire proximity sensor supplies the current required to operate the load, it is known as a sourcing sensor in this particular circuit. Replacing the 2-wire proximity sensor with a 3-wire proximity sensor will result in a setup like this. Although it might appear complicated, later in this video, you'll learn how to simplify it by breaking it down. Now, let's take a closer look at the internal circuit design of a 3-wire PNP sensor. Generally, it consists of a sensing element circuitry and a PNP transistor. The sensing element circuitry is designed to detect the presence of any nearby object. As soon as an object enters the sensing range of the sensor, the sensing element circuitry sends a signal to the PNP transistor to turn it on. All you need to know about the PNP transistor is it functions somewhat like a switch. It regulates the flow of current in the sensor. When the transistor turns on, it permits current to pass through the sensor, but when it turns off, it interrupts the current flow within the sensor. Solid-state 3-wire PNP sensors are classified as active devices and typically need a small amount of operating power, unlike passive sensors that do not. Out of the 3 wires connected to the sensor, 2 are used to supply the energy needed for the sensor to function. So, the brown wire, known as the power wire, is attached to the positive side of the power supply, and then the blue wire is connected to the power supply's negative terminal. The third wire, which is black, is identified as the signal output wire of the sensor that is going to connect to the input terminal of the load. The placement of the PNP transistor between the wire carrying positive voltage and the wire transmitting the sensor signal output is done because the PNP transistor is intended for positive switching. As a reminder, since the middle letter in the PNP is N and is short for negative, the negative side of the power supply should be electrically connected to the load's common terminal to complete the circuit. Assuming a light bulb as the load in this circuit, let's proceed with the working principle of a 3-wire PNP sensor. Whenever the sensor doesn't detect any metal object, the active line is low. Thus, the PNP transistor is off and behaves somewhat as an open switch. As a result, no current flows in or out of the PNP output and the light bulb is off. But detecting a metal object by the sensor makes the active line goes high and subsequently turns the PNP transistor on to act somewhat as a closed switch. As a result, it enables the flow of current from the power supply's positive terminal through the PNP transistor towards the sensor output and eventually to the negative terminal of the power supply via the load. So, the function of the PNP sensor in providing power to the load is why it is commonly known as the sourcing sensor. When substituting the light bulb with a PLC discrete input module, the process of connecting a PNP sensor to the PLC will be similar to the PNP sensor wiring to the light bulb. Nevertheless, two factors must be taken into account. First, PLC discrete input modules come in either syncing or sourcing configurations, and for the sake of this video, the syncing type will be discussed briefly. In this configuration, the negative end of the power supply is linked to the common terminal of the PLC. Also, the input channel of the PLC module is internally bonded to the ground connection. Second, the type of sensor chosen for use with a PLC must be compatible with the input module installed in the PLC to ensure proper functionality. The type of field sensor used in the industry must be complementary to the PLC discrete input module type. Now let's return to the circuit. Since you put the PNP or sourcing sensor here, you need a syncing PLC discrete input module to go along with it. To complete the circuit, connect the black wire, which represents the sensor output, to the input of the PLC module, and the power supply's negative terminal should be connected to the PLC module's common terminal. If a metal object is detected by the PNP sensor, the sensing element circuitry emits a signal to the PNP transistor to turn it on. This way, the transistor will behave somewhat like a closed switch. As a result, the flow of current starts at the power supply's positive terminal and passes through the sensor. Then the current enters the PLC input and returns through the PLC common terminal to the negative side of the power supply. Finally, let's learn how to test the PNP sensor to see if it works correctly. To do so, you need to get your multimeter into play. Also, think of 24 volts DC as your main supply to the sensor. You expect if the PNP sensor does not sense the presence of a metal object, the sensor's output voltage will be low, meaning the PNP sensor supplies almost 0 volts to the input of the PLC module. It's time to hook up the multimeter. Connect the red lead of the multimeter to the black wire of the PNP sensor and attach the multimeter's black lead to the ground. As anticipated, you can read almost 0 volts on the multimeter. Now you expect if a metal object enters the sensor detection range, the output voltage of the PNP sensor will be pulled up to almost nearly the same voltage of the power supply. As anticipated, this voltage is displayed on the multimeter as well. Note the voltage reading will consistently be 1 to 2 volts lower than the power supply voltage due to the transistor's influence. Don't forget to share your opinion about this video in the comment section. Also, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon to keep motivating us to produce more informative videos.